Assalamualaikum warahmatullahi wabarakatuh. We are from Group 38 and our project is about automated pest control system. Myself, Riga Tarik, I am with
I'm Ayas Kalana Pandit.
I'm Daniel Kevin Siboro.
And I'm Goldi Firman Pramana.
and we are going to present about the background, the demonstration of this system with Proteus, an explanation of the Arduino program as well as the result or output analysis. The objectives that we are aiming in this project are stated here. First, we want our iris sensor to be able to detect and send a signal from any incoming objects in the area. The spray or motor servo, in this case, will activate when receiving a signal from the sensor and successfully display the device status on the LCD along with the serial monitor as well to the log of the SD card. And the background is the pest control system serves a purpose to deter any pest in the surrounding area of the device itself. It utilizes IR sensor to detect any objects nearby and an additional IR sensor to widen the range of detection. As stated before, if an object is detected by one of the IR sensor, it will trigger an output to the LEDs and to the motor servo. Since Proteus has limited resources, the motor servo serves as an alternative or a representation of the pesticide spray. And the detection status is displayed on the LCD display and it is logged into the SD card. And the apparatus needed for this project are Arduino Uno, two IR sensors, two LEDs, one SD card slot, one motor servo, one visual terminal, and one 20x4 LCD screen.
Hello, I'm Ayas and I'm going to explain about the flowchart and the simulation of our project. So in the flowchart, the first thing is when the program starts, it will initialize the libraries that are included, the variables and the SD card. And right after that, it will displays our group number, which is 38 in the LCD display, and after that, it will read the IR sensors digitally by using the digital read function. And from here, there are two main outcomes, which is when the IR sensor detects an object or when the IR sensor does not detect an object. When it does not detect an object, it will display a clear string in the LCD display, and right after that, it will log the clear string into the SD card, and it will read the IR sensors again periodically, and if it detects an object, it will display a detected status in the LCD display. It will log spraying pesticides string to the SD card, and it will also turn on the LED indicator according to which sensor detects an object. So there are two sensors in our project, and last but not least, it will rotate the servo motor, which can be imagined as spraying a pesticide. So in the simulation, there are four main possibilities of outcomes. So in the first one, it is when both of these IR sensors does not detect any object. So as you can see, it is given a 0 digital input for both of these sensors. Oh, and by the way, the Arduino and these IR sensors are from external libraries from the engineeringprojects.com. So when it does not detect an object, the LCD display will show a clear status right here, and the motor servo will not rotate. And also the LED direction indicator does not switch on, which means that none of these upper or bottom sensors detects an object. So now let's move on into the second possibility, which is when the upper sensor detects an object. It is simulated with a 1 digital input to the IR sensor, and the LED direction indicator lights up, and it is the upper LED sensor that lights up, and from this LCD screen it shows a detected status, and the motor servo will then rotate to simulate spraying pesticides. Now let's move on into the third possibilities, which is when only the bottom IR sensor detects an object, which will turn on the bottom LED. It will also rotates the servo motor, and it will also show a detected status in the LCD display. And last but not least is when both of these IR sensors detects an object, which means that both of these LEDs lights up and the motor rotates, and the LCD display shows also a detected status. And let's move on into the Proteus, shall we? Okay, so here's the simulation, and these Arduino and these IR sensors are from external libraries from the engineeringprojects.com, as you can see right here. Now let's simulate. Okay, so as you can see, I gave 0 digital inputs to both of these sensors, which means that there are no objects being or pests being detected, and the screen shows a clear status right here, and none of these two LEDs lights up. So now what will happen if I turn one of these on? And as you can see, I just gave a one input into the upper sensor, and the upper LED will also light up, the motor servo will rotate, and it will show a detected status right here. So what will happen if I also switch the bottom sensor on? And as you can see right here, when both of these IR sensor detects an object, both of these two LED indicators also switched on, and it will still also show a detected status. And if the upper sensor does not detect an object, but the bottom sensor detects an object, it will still also displays a detected status, and the bottom LED will is still being turned on. And as you can see, if none of the sensor detects an object, it will displays clear, and none of this LED will also light up.
So now I will be explaining the code we will use for our project. Here we use 4 libraries, and we initialize our LCD with the respective pins, and we also declare our variables used for our components, like our servo variable, and also the variables according to the pins used for our Arduino, like here for our IR sensors, motor, and our LEDs. Here we have 2 integer variables that will represent the digital states of our IR sensors, and a variable called myFile for our SD card or for data logging. And here in our void setup, we initialize the modes of the pins used for our components. Here we set our IR sensors as inputs and our LEDs as outputs, and we attach our motor variable as the servo. And we start our LCDs with 4 rows, and we print Team38 pass control system and status to the first 3 rows. And here we start our SD card, and we have a control where if the SD card does not begin, then it will print out initialization failed. And here we open our status.txt file, or our text file that we will use for data logging, and we will first try to print some text into our text file. And if this does not work, then it will print out error opening status.txt to the serial monitor. And again, we open our text file to test reading from the text file, and see what is inside the file. And here in the loop, we assign the val and val1 to the digital values of our IR sensors. And here, while val equals to 0 and val1 equals to 0, meaning there's nothing that's being detected by our sensors, then both LEDs are off and we print clear to our LCD, and also we print clear, or we write clear to our status.txt file. But if either val equals to 1 or val1 equals to 1, meaning either our sensors detect something or detect the pest, then it will print detected in our LCD, and we will open the status.txt to print spraying pesticides. And if val is 1 while val1 is 0, then only the upper LED turns on, while if val equals to 0 and val1 equals to 1, then only the lower LED turns on. Else, when both detects the pest, meaning val equals to 1 and val1 equals to 1, then both LEDs will turn on. And here we also turn our servo to simulate the spraying of pesticide.
Here I want to explain more about the SD card memory. So basically from the SD card memory we can edit properties to path the card image file by searching using star like this. So your file will show all the EMA file. Just click here and then open after it. So just click OK, and then after that we can run this simulation. So here the pest control system status is clear, and we just make a small experiment here to make it change it. So after we get the data, and then I want to this first to turn on this one. Okay, just wait a moment please, and then okay, so we can open the Ultra ISO so we can see the status of the of these our property. So we just click open our SD card image here, just click open, and then we can see our result of the output printing. So just show like this. It is same as the virtual terminal that should be shown here, and then we can see this status is clear. Why this is clear? Because the sensor is not triggered, so it is spraying pesticides if the sensor is triggered, just basically like that. And then for accessing the accessing our log, this output log, we just click open with same directory with our SD card properties before. It's basically like that, and we can continue our this printing by just simulating again. Thank you very much for watching our presentation. Wassalamualaikum warahmatullahi wabarakatuh.